The structures of sodium chloride and chlorine are shown below. So on sodium chloride and chlorine. So what's the difference? This is an ionic structure where this is a simple molecular structure. Melting points of sodium chloride is 801 degrees Celsius, and melting point of chlorine is a negative 101 degrees Celsius. Explain in terms of structure and bonding the difference between melting points of these two substances. So because of their different structures, they have different bonding. So how are their structures different? Well, on the left hand side, we have an ionic structure. How'd that happen? Ionic structure, and it's held together by these strong ionic bonds, so strong forces are holding it together. Hence the melting point is really high, and you can see that it's really high. For over here, so two Cl atoms are held together by a covalent bond over here, one covalent bond, right? But that doesn't dictate its melting or boiling point. What does is, between each molecules there are weak intermolecular forces. What's wrong with my pen? Weak intermolecular forces, and they dictate the melting point of chlorine or the boiling point of chlorine, and those are very weak in nature. I mean, that's the name. So this is what you have to do. Each point is one mark, so you identify correctly that sodium chloride is an ionic structure, so it has strong bonds holding it together, strong ionic bonds, so that's why it's really high. And for chlorine, you have to identify structure. It's simple covalent with weak intermolecular forces between it, right? I think I mentioned weak twice. I should have said it's a simple covalent structure with weak forces, so the boiling point is really weak. So these 4 points is what I need to use to formulate my answer. Let's try doing that now. So sodium chloride is an ionic structure and is held together, and the ions are held together by strong ionic bonds. So we know there are ionic bonds, and ionic bonds are generally strong, but in this context we have to also emphasize that they're strong. That's why it takes a lot of energy to melt it, to separate them. Strong ionic bonds. Let's say hence a lot of energy is required to melt NaCl. Whereas on the other side of the spectrum you have or we should say chlorine, just outright chlorine, could say Cl2. Chlorine is a simple covalent structure with weak intermolecular forces, intermolecular or van der Waals molecular forces, and is easily melted or melted, right? And that's the context. explain why molten sodium chloride conducts electricity, but solid sodium chloride does not. Well, in a solid, the ions are not free to move. So it's a 1 mark question. Just highlighting that fact is fine. In molten sodium chloride, the ions are free to move. But in a solid, they are held together in fixed positions and cannot move around or carry a charge. They are held together in a fixed position. In a fixed position. ठीक है. Dot and cross for sodium chloride, but note that they want all the electrons, not just the outer electrons. So this is going to be tricky because I can't draw circles on the iPad. Let's try doing it anyway. Alright, you have sodium with the inner shell, then you have a shell, and the third shell is gone because it loses 1 electron, so it has a positive charge. And then we have chlorine, which is going to be even trickier because it has 1 more shell. Okay, that's chlorine's 1, chlorine's 2, and chlorine's 3. Right? Now I'll make sodium's electrons pink because it looks better. 1, 2, 3, 4. Gotta change them. 1, 2. Right? I would color them, but it's just a pain. And 1 electron from sodium. And should have given it more room because this has a positive charge. I want to write that. This has a negative charge. Dot and cross for sodium chloride. Refer to these equations to explain why electrolysis involves both oxidation and reduction. While at the negative electrode, what's going on? Electrons are being gained. Electrons are being gained by sodium. So what is that? Rig. Reduction is gain of electrons. So at the negative electrode, you can say reduction is taking place. What is the... and the cathode, sodium ions are being reduced. As they are gaining electrons. Gaining electrons. And at the anode, chlorine is oxidized. Ions, keeping it consistent. Oxidized as it loses electrons. Now this is different from other questions because it's not talking about explain why this is a redox reaction. So we'd say as both, if that was the case, Explain why redox is taking place. Well, then we'd say as both oxidation and reduction are taking place, hence it's a redox reaction. But it's saying, hey, can you state why? Can you explain why electrolysis has both oxidation and reduction? And we're highlighting where oxidation is taking place and where reduction is taking place. And in essence, or in in essence, we're explaining why both oxidation and reduction is taking place. Chlorine reacts with excess ammonia to form hydrogen chloride and nitrogen. Construct an equation from this reaction for this reaction. Well, it's telling you what's being made. Let's try doing it. Chlorine reacts. Chlorine is going to be Cl2 with excess ammonia is going to be NH3, and it tells you what's being made. It's going to be HCl and nitrogen. Now the challenge is now to balance it out. Let's see if we can do it. So 3 hydrogens. Let's make it 6 hydrochloric acid. So we can put a 2 over here, so the nitrogens are balanced out. And if we put a 3 over here, now it looks all balanced. 3Cl2 plus 2 NH3s will give you 6 HCl. That makes sense. And 2 N2. Oh, just 1 N2. Right. Alright, this is just explaining a bit of math. So what you say is bond breaking. You say bond breaking bond breaking absorbs energy, right? It's endothermic. And bond forming releases energy. So this reaction will be exothermic. Reaction is exothermic, or reaction is exothermic because more energy is released. What's wrong with the pen? More energy is released than absorbed. Technical difficulties. What's wrong with the handwriting? Something's wrong with my pen. Alright, I hope that makes sense. Let's move on to the next part. Alright, this is an interesting question, but really straightforward. So it's saying 1 mole, if 1 mole of oxygen reacts, it'll give you negative 392 kilojoules. And the negative means it'll give it to you rather than take it away from you, because it's exothermic, it'll produce it, right? So if 1 mole of oxygen reacts, it'll produce negative 392 kilojoules of energy. I gotta figure out how much will 48 grams, units changing, of oxygen will give me, right? Can I convert this into moles? 48 into moles, I think that's going to be 1.5 moles. How do I know? 48 divided by the MR of oxygen, which is 32. So that gives me 1.5 moles. So 1.5 moles of oxygen will give me, if 1 mole is giving me 392, 1.5 will give me 392 times 1.5, right? And I think that comes down to 588. The important bit over here is that energy, it's saying energy released. Or if it doesn't say energy released, or like energy change or delta H, you have to say It's negative 588. Right now you can get away with it. Why? Because it says energy released, so that's already taken into account. They won't penalize you if you don't put a negative mark. But be on the safe side, just always put a negative mark. Also, if the units aren't given, don't write down joules over here. Write down kilojoules, right? Okay. Name a pollutant that depletes ozone in the upper atmosphere. So this is we haven't done, so I'll skip this bit for now. We don't need to know this. This is pollution in air, which we'll do at the end. We'll focus on that when we get there. Okay. So the same reaction is showing up as a reversible reaction, right? Oh no, it's not the same. Okay, so ozone is turning into oxygen and it's a reversible reaction. The reaction reaches equilibrium if it's carried out in a closed system. Okay. The reaction is studied at a temperature of 400 degrees Celsius. Describe and explain what happens to the position of the equilibrium if the pressure is increased. Well, if the pressure is increasing, the side with the fewer amount of moles will be favored. So if I'm looking at the equation, which side has the fewer moles? You have 2 moles of ozone here, but 3 moles of oxygen. So because gases occupy the same volume, they're just more here than over here. So there are more particles over here. So this side would be favored as you increase the pressure. They'll be more tightly packed, right? So it's a 2-mark question. So you have to say what's going to happen and why it's going to happen. So we know what's going to happen. What side of the equilibrium will be favored, or which way will the equilibrium be moved? The equilibrium will move towards the left. The equilibrium will move towards the left. That's 1 mark. As increasing pressure favors the side with the least amount of moles. So you have to explain it as well, with the least amount of moles. All right, so the reaction is studied as 25 atmosphere pressure. So they redo the experiment. Now they're keeping the temperature constant. Now what they're going to do, the pressure constant. Now what they're going to do is change the temperature. So they're saying the temperature is going to decrease. What will happen to the equilibrium? So if I go back to the equation, I notice that my equilibrium, like towards the right hand side, as you go towards the right hand side, it's an endothermic process. So decreasing the temperature favors the exothermic side, right? So if the forward as you go towards the right is endo, the backward is exo. Let me write that down. So the forward is endo. This is what's highlighting what the forward is. If that's endo, obviously the backward will, if one is producing heat, one is absorbing heat, the opposite will produce heat. So as you go more towards the left, it's going to be more and more exo. And decreasing the temperature will favor the exothermic side. So that's what you write down. 1 mark for correctly identifying the side. The equilibrium, will move towards the left hand side. As that is exothermic reaction. That is exothermic. Okay, 1 mark for each color. Let's move on. Describe and explain what will happen to the rate of the reaction if the temperature is decreased. Well, now again, you gotta understand that the rate of the reaction is something different from the equilibrium of the reaction. Now, equilibrium has a forward rate and a backward rate, whereas a regular equation will just have rate. So it's easy to get confused between which side is favored and which side isn't. So what will happen to the rate of the reaction if temperature is decreased? Well, what happens to the rate of reaction of any reaction if the temperature is decreased? The rate will slow down. The rate will decrease. What is going on? Rate will decrease. The rate will decrease. Why will it decrease? Because particles have, I'm just gonna write it in points because my hand really hurts. Rate will decrease because particles have less energy and there are less successful collisions. All right, we have an ester being formed. Now it's complicated what's really going on. We haven't really studied this, but this reaction is taking place. So this is called an ester, reacting with an OH ion to form just ions and then this thing, right? So these are ethanoate ions. This is what the question is talking about. The graph shows the concentration of ethanoate ions as they change as the reaction proceeds. So you start with 0 because, ethyl ethanoate is not an ion right now. And as it proceeds, it forms more and more ions until all of it has turned into ions. So let's see what the question is asking. The question says, use the information in the graphs to deduce the mass of the ethanoate ion in 200 centimeter cube of the solution when the reaction is complete. So 200 centimeter cube is completely irrelevant for this, at least this part. Let's see if we can do it. So we need the concentration or the exact moles of it, right? Yeah, so okay, we need the volume. We need this volume because we need to know what the volume, what the total moles are. And I can only find the total moles if I know its concentration and its volume. So what is the concentration over here? And I'm gonna bet going to be 0.45 at the end, right? That's the concentration in moles per decimeter cube. I know the concentration, I know the volume. Can I figure out the moles of these ions? Yes, I can. Let's try doing that. So the moles are concentration times volume, right? Yes. So 0.45 times 200. I want mine in decimeter cube. That's going to be 0.2. And what's that? What is that? Okay. 0.45 times 0.2. That's going to be 0.09 moles. 0.09 moles. I have to find the mass. For that, I know the moles. I got to figure out the MR for the ion. Why does it do these things? So the MR for the ethanoate ion, which is CH3COO. That's it, right? Just the ion. Uska mass chahiye. So that's not with anything else attached, just this ion. So that's 2 carbons, 2 oxygens, right? 2 carbons, 2 oxygens, and 3 hydrogens. So what is that? I think we can do it. 32 plus 24. 32 plus 24. I'll just do it. like that. 32 plus 24 is going to be 6 and 5, 56 plus 3. That's 59, right? So this is 59. So the mass is going to be 59 times the moles, 0.09, which is 5.31 grams. 5.31 grams. Let's move on. Use the information in the graph to calculate the average rate of reaction in moles per decimeter cube during the first 300 seconds. Now this is going to be an issue if I go back. The app doesn't allow me to do that. So I'm going to look at my screen. So, but it's trying to say, let me see if I can just bring a screenshot of the first few. I think I can. Let's see if that'll work. The first 300 seconds. Yeah. Let me see if I can paste it now. Range, edit. How do I paste? Alright, it's gonna be a challenge. I did copy it. Let's see if I can. For the first 300 seconds, that's the 300 marker. Let's see how high it goes. Goes here till here. What is that? 2, 19, 18, 17. So 0.17. So it produced 0.17 worth of concentration in 300 centimeters. No, 300 centimeters, right? 300 seconds. So the average rate is just concentration over time. Concentration over time. So average rate is 0.17 moles per centimeter cube per 300 seconds. And that's going to come out to what? 5.67 times 10 to the power minus 4, I think. Yeah. You can round that off if you want. And that's the answer. Make sure you write your answers in the space provided as well. 10 to the power minus 4. Describe and explain using kinetic particle theory the change in the rate of reaction with time. 3 marks. So let's just dump everything we know about particle theory and rate of reaction. As the reaction progresses, as the reaction progresses, dear diary, as the reaction progresses, the concentration of the reactant, the concentration of the reactants, concentrations, the word is important because concentration, not number of particles. Concentration of the reactants decrease as more and more are converted into ethanoic ions. Ethanoate ions decreases. Concentration of the reactants decreases. The collision frequency also, as a result, collision frequency also decreases. And as a result, or hence, or whatever, let's put a full stop there. Hence, rate of reaction slows down. Wow. All right, another one. Isotopes this time. 2 isotopes of phosphorus are here. The phosphorus 31 and phosphorus 32. Notice how the proton number for the phosphorus is the same because that's what phosphorus is. It just means it has 14 protons. Protons number for elements will never change. The state one difference and one similarity between these 2 isotopes. Well, they're I guess the number of neutrons is different. That's the most obvious. But that could also, let me just write this down. Number of neutrinos. Neutron and neutrinos aren't the same thing, are not the same thing. Number of neutrons. But you can also write stuff like mass number, nucleon number, one extra neutron if you want to phrase it like that. But yeah, they all mean the same thing, or are implying the same thing. They don't mean the same thing. What's the similarity? Well, say number of protons. And let's just stick to that. Same number of protons. Phosphorus forms a simple molecules which have a relative molecular mass of 124, suggests the formula of phosphorus molecule. And that's easier said than done, or easier done than said. Yeah, I think the latter. Periodic table. I'm just opening the periodic table, which it won't let me. Right. Okay, phosphorus has a mass. Oh, it was right there. 31. Phosphorus has a mass of 31, and the molecule of phosphorus has a mass of 124. So if I had the courage to divide 124 by 31, I would get 4. And that would be the mass of the molecule. Much like oxygen, let's say I don't know how many oxygen atoms are there in a oxygen atom, oxygen molecule, but I know its mass is 32 and each oxygen is 16 by weight, so there needs to be 2 atoms in the molecule, right? Same logic here, we have a different molecule. So state the formula of the phosphorus molecule. Well, it's going to be P4. Phosphorus has a low melting point and does not conduct electricity. Explain why phosphorus has a low melting point. Because it's a simple covalent. It's just 1 mark, so we don't have to talk too much, because it just has weak forces. But I'll go the extra mile. It is a simple, I just like saying simple covalent. Simple covalent molecule. It is a simple covalent molecule and has weak intermolecular forces. Explain why phosphorus does not conduct electricity. Because it has no free moving ions or electrons. No free moving ions or electrons. Complete the table for 31, phosphorus 31 with a ion, which is an ion with a 3 negative charge. Number of neutrons, I don't know, but let's start with number of protons. That's the easiest. It has 15 protons, so neutrons it should have 16. Why? Because the sum of neutrons and protons is 31 and proton is 15, so I'll do that math over here. So n has to be 16, right? And it's electronic configuration with a 3 minus charge. So it has 15 electrons. It should, the phosphorus atom would have 15, but right now it has 18. And they would align themselves as 2, 8, and 8. So 2, 8, and 8 is the electronic configuration for phosphorus. Phosphorus forms a compound called phosphine, pH3. Phosphine. pH3. Now phosphorus is right below nitrogen. Now bells should be screaming in your head They don't really want you to draw phosphine, they really want you to draw the same electronic configuration for, or the dot and cross for ammonia. Completely identical, right? Draw the dot and cross diagram to show the bonding in the molecule of phosphine. Only draw the outer shell electrons. Blessed art thou, Cambridge International Examination, because they only asked to draw outer electrons only. So phosphine is very identical to ammonia, where nitrogen is very identical to hydrogen. Oh, sorry. Phosphorus is very identical to nitrogen. That's phosphorus, that's hydrogen, that's another hydrogen, that's a third hydrogen, and we have crosses for hydrogen and circles for, or these things for. Take care. And let's try drawing it's gonna look really dirty by the time I'm done drawing the circles, because I have no help for this. Yeah, maybe that's not too bad. And maybe I should erase this and take these up here. Okay, that's not too bad, I guess. And the last dot and cross, I've got to make the key. Phosphorus over here is, maybe you guys should draw dots rather than dots and crosses, right? It's called dots and crosses for a reason. And I should encourage that by coloring in these dots. I think it just looks neater if I just draw the circles. Not too bad. Okay. Phosphine will ignite in air to make water and phosphorus 5 oxide. What is phosphorus 5 oxide, children? Phosphorus 5 is highlighting the oxidation state for phosphorus, and oxygen has a state of 2 minus. What's this going to be? It's going to be P2O5, right? That's how you balance it. Phosphorus oxide, construct the equation for this reaction. Okay, phosphine is PH3 again, reacting with the oxygen in the air to make P2O5 and H2O. Let's try balancing this out. What do I want to start with? For sure, I'll have two phosphines over here, because there are 2 phosphorus atoms on the right hand side. Now I have 6 hydrogen, so this has to be a 3, right? How many oxygen atoms do I have on the right hand side? I have 5 plus 3, a total of 8. I'll take that here and put a 4 over here, and I think we're balanced. Yeah. Okay, easy does it. That's 12 marks, easy. Come, easy go. Alright, electrolysis is often used in the extraction and purification of elements. Magnesium is manufactured by the electrolysis of molten magnesium chloride. Right, equations for the 2 electrode reactions that occur during the electrolysis. You just have to state the equations, but I'll go one step further and say at the cathode, now if you're not confident, don't write it, right? Like, cathode gives out electrons, so magnesium starts as Mg2+, because it's, here. Chlorine starts as Cl-, so magnesium 2+ will go to the cathode because it has a lot of electrons, and it'll turn into magnesium metal. And at the anode, you'll see 2 chlorine ions giving out electrons, right? This is oxidation at the bottom because that's loss of electrons. Just an extra fact, this is reduction, oxidation. Copper can be purified using the electrolysis of aqueous copper sulfate. Purification of copper. What is used at the anode? So copper will first, what happens to impure copper is a solid which first turns into an ion, if you remember, in aqueous, then it goes to form pure copper again. The first step can only happen at the anode, right? Because it loses its electrons. This is the anode part, and this is the cathode part. So what is used at the anode? What's going to be impure copper, or raw material, or just impure copper. I think that's simple for everyone. What is used at the cathode? Just a sample of pure copper, so more pure copper can stick to it. You don't want to use anything else. If you use graphite, technically you can, but it's just that if you have graphite, all that new copper is going to fuse onto it. Then who's going to separate it? Why make your life more difficult? Just use copper, and that's why you use pure copper. Chlorine, okay, now we're moving on to moles. Chlorine can be made by the electrolysis of concentrated aqueous sodium chloride. Okay. Overall process is here. 55 decimeter cube of 3.5 mole per decimeter cube of aqueous sodium chloride is electrolyzed. What is the maximum volume of chlorine that can be formed? So we're debating between, the debate is between sodium chloride and chlorine, for which their ratio is for every 2 of these, you'll end up making 1 of this, right? So let's figure out how many moles of sodium chloride do you have. You have 55 decimeter cube of 3.5 mole per decimeter cube of this. So that's just going to be 3.5 times 55. Let's do that. 3.5 times 55 is, you have a lot of it. You have 192.5 moles will produce, dividing it by 2, because the ratio is 1:2, you will end up producing 96.25 moles of chlorine. And by the way, didn't really show the calculation, but you should show the calculation in case, your main answer, your final answer is wrong, so we can find ways to give you marks if you've done that correctly. But if you just skip it like how I was doing it, you might get 3 marks for a full correct answer with enough working, or you'll end up getting 1 or 0. So make sure you also do the working. Sometimes it's a little too easy, I skip the working. Then again, I don't have to sit for the exam. Okay, so mole of sodium chloride, how did I calculate this? It was the concentration times the volume, which is 3.5 times 55. No conversion needed, they're all in decimeter cube. And 96.25. Now, maximum volume. So if you remember how we divided our moles into step, this was our step 1, identifying ratios was our step 2. Now convert it, we have the final answer. Now we have to convert it into the value in which the question is asking what, but it doesn't care for moles, it wants the volume of chlorine. And that's easier done than said, right? Because any volume of, why do I do these things? Any volume of gas will be the mole of its gas time 24 decimeter cube. The moles are 96.25, and you'll end up producing 2,310 decimeter cube. 2310.